This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on inverse functions. So we'll begin with the function f of x is 3x plus 7. That is a function. We want to take the inverse of that function. With inverses, x values become y's and y values become x's. So that'll be the heart of the idea that we're going to be using here. So we're going to rewrite f of x as y. So just making that small substitution. So we've written it in function form to xy form. And again, for an inverse, x becomes y becomes x. We switch those two things. So I indicate it that way. So we're going to rewrite this then as x equals 3y plus 7 when we make that switch. And then our next step is to solve for y. So we'll do that, subtracting 7 from both sides. So those 7's go away and we get x minus 7 equals 3y. And then solving for y, we're going to divide both sides by 3. So that gives me y is equal to x minus 7 over 3, and that is my inverse function. Now just a quick note, not every function has an inverse. A function has to be one-to-one, which means if you would draw the graph, it would have to pass the horizontal line test. Y equals 3x plus 7 is a line with a slope of 3, so of course any horizontal line will only cut it in one point. So just something to keep in mind as we're looking at these various inverse functions. Our next example is f of x equals the square root of 4x minus 9. So we're going to rewrite it as y equals root 4x minus 9, and then for inverse functions, x becomes y and y becomes x. Rewrite as x equals the square root of 4y minus 9. Next goal then is to solve for y, and I have to figure out how to eliminate a square root. So we'll square both sides. Squaring the left side, x squared. Squaring the right side, square root of 4y minus 9 squared will leave me with 4y minus 9. So now we're at the point where we have x squared equals 4y minus 9. Let's add 9 to both sides. On the left side, x squared plus 9 on the right side, the 9's go away, it'll just be 4y. So x squared plus 9 is 4y. We want to solve for y. So we'll divide both sides by 4, and that gives me y is x squared plus 9 over 4. And that would be the inverse function. This would pass the horizontal line test. Again, it's a square root function. This frankly doesn't, but it's not terribly important to be concerned with that because this function will have an inverse because its graph is appropriate. Okay, next up we have f of x equals 5 over x plus 1. Rewrite using x's and y's. X becomes y becomes x. Rewrite then as x equals 5 over y plus 1. And we want to solve for y. So how do we do this? When you have a denominator, we're going to multiply both sides by that denominator, so we eliminate the fraction on the right side. Multiply the left by y plus 1, multiply the right by y plus 1. On the right side, the y plus 1's will cancel, leaving just 5. On the left, we'll have to distribute. X times y is xy, x times 1 is x. So we'll have xy plus x on the left side and 5 on the right side. Goal is to solve for y. So subtract x from both sides of the equation. So it'll give me xy equals 5 minus x. And then to solve for y, we're going to need to divide both sides by x. Dividing both sides by x, we get y equals 5 minus x over x. So that is our inverse function. F inverse of x will be 5 minus x over x. Okay, our next example is f of x equals 2x plus 1 over 3x minus 5. The algebra here gets a little tricky, so we've got to be extra careful. First step, as always, is to rewrite f of x as y. So we'll say y equals 2x plus 1 over 3x minus 5. For an inverse function, x becomes y and y becomes x. So this will be x equals 2y plus 1 over 2y minus 5. And then our goal is to solve for y. Now, the way we're going to have to do this is we're going to need to multiply both sides by the denominator, multiply both sides by 3y minus 5, and then attempt to isolate y. get all the y's on one side, get all of the other things on the other side, non-y's. So here's what we start with. Multiplying both sides by the denominator. The denominator is 3y minus 5. Multiply the left side by 3y minus 5. Multiply the right side by 3y minus 5. On the right side, the 3y minus 5's cancel. They divide out. All that's left is 2y plus 1. On the left side, we have x times 3y minus 5. Distributing here, 3xy minus 5x. Distributing on the left side, 3xy minus 5x. On the right side, we just have 2y minus 1. Now recall that our goal is to isolate the y's. I have y's on both sides. 3xy is on the left, 2y is on the right. I need all of the y's on the same side, and all of the non-y's on the other side. So how are we going to do that? You'll notice I've decided to subtract 2y from both sides. That'll get all of the no more y's on the right side. All of the y's will be on the left side. But then I need to get rid of this minus 5x. You'll notice I've added 5x to both sides. So the 5x's here cancel, and I'll have 1 plus 5x on the right side. Left side will be 3xy minus 2y. Right side will be 1 plus 5x. So we've successfully isolated the y's on the left side. Now I've got to solve for y. I will factor the y out of that left side. So if I factor out this y, it'll be y times quantity 3x minus 2. Divide both sides by 3x minus 2 to get y by itself. 3x minus 2's cancel. And I have y is 1 plus 5x over 3x minus 2. And that, of course, is our inverse function. So f inverse of x will equal 1 plus 5x over 3x minus 2 after a lot of significant algebra. Okay, we've got one more problem to compute the inverse function. We'll take a look at f of x is the cube root of 7x plus 5. This does pass the horizontal line test. That's not a problem. So we're going to go ahead and rewrite f of x as y. And then we switch the x's and the y's. So it'll be x equals the cube root of 7y plus 5. And then our goal, of course, is to solve for y. So how do we do that? We have x is the cube root of 7y plus 5. Let's cube both sides. So cube the left side, cube the right side. The left side becomes x cubed. The right side becomes 7y plus 5. Then our goal is to solve for y. We'll subtract 5 from both sides. So x cubed minus 5 is 7y, and then divide by 7. X cubed minus 5 over 7 will equal y. And of course, that is our inverse function. And that will conclude this lesson.